Okay, so let's start the session. So, hello everyone. I hope you all are doing good. I am Sambhav and I will be your senior math instructor for this session. Today, we are going to continue our discussion on Introduction to Trigonometry. So, in the previous session, we talked about the introduction part, what are trigonometric ratios. We even solved some problems related to trigonometric ratios. In this session, we are going to continue our discussion on this chapter and we are going to talk about trigonometric identities, how to solve different problems related to identities and everything. Also, I will tell you how to create the table that will be useful not only in this chapter but also in the next chapter, the value of some specific angles. That also I will tell you how to create that table very easily. You don't need to remember the values exactly. If you can, well and good. If you are not able to remember the values, I will tell you the trick to create that table. Okay. Now, I'm just waiting for 2-3 minutes so that everyone can join. Let me tell you one more thing. If you are having any doubt related to this chapter, you can ask us in the chat box or also in the comment section. So we will be more than happy to help you. So just wait for 2-3 minutes so that everyone can join, then we are going to start. So till now we understood what is trigonometry. No, trigonometry is not a single word, it's a combination of two words: trigonon, metron. Trigonon means triangle, metron means measurement. So we are studying the measurement of a triangle. In triangles there are basically three major components: sides, angles and vertex. So trigonometry is nothing but the study of relationship between, sorry. So trigonometry is nothing but the study of relationship between the sides and the angles of a triangle. In 10th class, we are majorly dealing with right angle triangles. Right angle triangles means that one of the angle in the triangle is exactly 90 degrees. Then we know the concept that in a right angle triangle there is one side which is longest, that is opposite to the 90-degree angle, also known as hypotenuse. Then the other two sides are base and perpendicular depending on which angle we are referring to, correct? All these things we have understood in the previous session. Now in this session I think it's time to start the session, right? Now in this session majorly we are going to discuss trigonometric ratios of some specific angles. So there are some specific angles that you are going to use in 10th class. What are the values of the trigonometric ratios for those angles? We are going to discuss this part. Then trigonometric identities. Identities we have already we are already familiar with identities, no? Like a plus b whole square, a minus b whole square, a square minus b square. These are algebraic identities. In this session we are going to discuss trigonometric identities. Then problems, of course, the most important part: how to solve problems based on this chapter, how to approach them, how to solve them, prove them, correct? And then we are going to summarize the chapter. That's it. So this is very easy chapter. Please don't judge the chapter because of name or because this chapter has been included for the first time in your entire life. So don't judge this chapter because of that. This is very easy chapter. You can easily score in this chapter. I will tell you how. Now, first thing, that in the previous session we discussed this table, correct? This table do summarize what are trigonometric ratios, how to find them, actually what are their values if a triangle is given. So 6 trigonometric ratios are sine, cos, tan, cosecant, secant and cot, correct? Sine theta is perpendicular by hypotenuse, but again I'm telling you, perpendicular, hypotenuse is fixed side, the side opposite to the 90-degree angle. But what about perpendicular? Perpendicular is that side which is side opposite to the angle which is being referred. Suppose if we are talking about triangle ABC, let me use my pen. So if we are talking about triangle ABC, so this is angle 90 degree now. Side opposite to this angle is the hypotenuse. Okay, fine. Now, depending on which angle we are referring to, we can have different perpendicular, different base, correct? Suppose we are referring to angle C. Then side adjacent is the base of this triangle. So this is the adjacent side BC, so this is the base. Then side opposite is the perpendicular, so this is perpendicular. Now suppose if we are referring to angle A, then side adjacent is AB, so this is base when we are referring to angle A, and BC will become perpendicular when we are talking about angle A. So depending on which angle we are referring to, we can have different perpendicular, different base. But you can understand it like this: side adjacent will always be the base, side opposite will always be the perpendicular. Okay. Now cos. Cos is nothing but the complementary of sine. So full name is cosine, but in short you can write COS, cos. Cos theta is base by hypotenuse. This is the basic formula. Tan, this is short form. Full is tangent. Tangent is perpendicular by base. Then cosecant is nothing but the reciprocal of sine. As I told you in the last session, that there are three primary trigonometric ratios. The other three are nothing but the reciprocals of the primary ratios. So cosecant is reciprocal of sine, 1 by sine. So if sine theta is perpendicular by hypotenuse, then 1 by sine would be what? Hypotenuse by perpendicular. So cosecant theta is hypotenuse by perpendicular. Secant is nothing but the reciprocal of cos. So 1 by cos. Cos theta is base by hypotenuse. 1 by cos would be hypotenuse by base. Cot is reciprocal of tangent or tan. So 1 by tan. Tangent is perpendicular by base. So 1 by tangent will become base by perpendicular. So this we understood. This we can easily remember. There's a memory trick also, right? I told you in the last session, some people have curly black hairs till painted black. Correct? This memory trick you can use to remember these ratios. Correct? Now, standard angles. In 9th class, mostly we are dealing with these angles only. One angle is fixed. In the triangle that is given to us, suppose one angle is having fixed value, that is 90 degree, because we are dealing with right angle triangles, correct? The other angles, both the values are complementary to each other, correct? Complementary means their sum is always 90 degrees. Now, mostly you are going to deal with 0 degrees. If suppose one angle is 0, then other one is 90 degree. So it means we need to deal with 90 also. If one angle is 30 degree, then other angle is 60 degrees, correct? So we are dealing with 30, 60. And if one angle is 45, then the other one is also 45. So it means we need to deal with 45 degrees also. So these 5 angles are what we are gonna deal with in 10th class. In this chapter also, but mostly you are gonna use these values in the next chapter, where we will be finding heights and distances depending on different scenarios, correct? So this is not difficult. Now, what are their values? I will tell you a trick to create a table with the help of which you can easily remember the values. The table will look something like this. Here in this table, I will create 6 columns and 8 rows. In this table, as you can see, all the common angles are written here: 0, 30, 45, 60 and 90. And all the 6 trigonometric ratios are written here: sine, cos, tan, cosecant, secant, cot. Correct? Now, how to fill up the values? What is sine 0 degree? What is the value? It should be written here. Sine 30 degree should be written here. Sine 45 here. But how to create this? What is the trick behind this? If you are not able to remember this completely, then I'm gonna tell you a trick now. You remember the counting, no? Counting numbers, whole number starts from where? 0. So I will do one thing. I will write 0 here, 1 here, 2, 3 and 4. You can do that. 0, 1, 2, 3, 4. You need to write this first. Then you will divide each value by 4. Each value by 4. Easy, correct? Now you are gonna put under root. Now find this value. 0 by 4. 0 divided by any number is always 0. Under root 0 is also 0. So this will be 0. So sine 0 degree is 0. Then sine 30 degree is under root 1 by 4. Under root 1, 1. Under root 4, 2. So under root 1 by 4 will become 1 by 2. Under root 2 by 4. 2 and 4 are divisible by 2. So it will become under root 1 by 2. Correct? Under root 1 by 2 doesn't have any specific whole number value. So we will go with under root 1 by 2 or 1 by root 2 because under root 1 is 1 only. So it will become 1 by root 2. Under root 3 by 4. Under root 3, okay, we can leave it as it is, under root 3, and under root 4 is 2. So this value will become root 3 by 2. 4 by 4 is 1, under root 1 is 1 again. So this will become 1. Now you know all the values of sine. Sine 0 degree, sine 30, sine 45, sine 60, sine 90. Correct? What about others? Okay, do one thing. All the values that you have here now, you're gonna write them in opposite way. Last value you should write first here in cos. So what is the last value? 1. So I will write 1 here. Second last value I will write here root 3 by 2. Then third last value 1 by root 2. Then this value will appear here 1 by 2. This value will be the last value of cos. Now we have all the values of cos theta. Correct? So this is looking a little bit clumsy, the sign values. So let me erase and let me put the single value only. Now because you know the trick now, na? First you are gonna write 0, 1, 2, 3, 4. Then you will divide each value by 4. Then you will find the under root. What is tan theta? Tan theta is perpendicular by base, correct? And last time I told you that tan theta can be found using one more method, and that is sine theta by cos theta. So we are gonna do this only. We are gonna divide these values with each other. Sine theta by cos theta will be the value of tan theta. 0 divided by any number, 0. So tan 0 degrees is 0. 1 by 2 divided by root 3 by 2. 2 and 2 are gonna cancel each other. We are left with now 1 by root 3. 1 by root 2 divided by 1 by root 2. 1. Same values when they are divisible is gonna give us 1. Root 3 by 2 divided by 1 by 2. 2 and 2 cancel. We will be left with root 3. 1 by 0. 1 by 0 is a fraction, correct? Fraction usually tells us that what portion we are considering out of how many. The number written in numerator is telling us how many portion we are considering. The number in denominator usually tells us out of how many, the total number of portions. Here the fraction will become 1 by 0. So it means we are considering one part out of total 0 parts. This is not possible. So this situation as of now is not defined in mathematics. So the value will become 1 by 0 will become not defined. Okay. Now you are gonna do one thing. Either you can find for cosecant theta, it would be reciprocal of sine theta. So find the values of reciprocal of sine theta. So 1 by 0, again not defined situation. So I will write ND in short. Then 1 by 1 by 2. So it will become 2. 1 by 1 by root 2. It will become root 2. 1 by root 3 by 2. It will become 2 by root 3. and 1 by 1, 1. Secant theta is reciprocal of cos theta. So 1 by 1, 1. 1 by root 3 by 2, 2 by root 3. 1 by root 2, root 2. 1 by 2, 2. And 1 by 0, not defined. Now, if you realize that this row and this row, the numbers are written opposite, correct? Whatever value is first here, it is the last value of this row. Whatever is the value here in the end, it is the first value of this row, correct? So they are written in the opposite order. Cot theta can be found using 1 by 10. So again, 1 by 0, not defined. 1 by root 3, root 3. 1 by 1, 1. 1 by root 3 is 1 by root 3. And 1 by not defined is 0. It will be 0. Now, look at these two, tangent and cot. Are they written in opposite order? Yes, they are. So it means there are 2-3 ways by which you can create this table easily. But you are not remembering anything, correct? You are just only performing basic operations and still you are getting the same table. So if you are not liking my handwriting, let me show you the computer written table. So this is the table that we are talking about. Sin theta is when it is 0, it will give you sin 0 value. Sin theta when it is 30 degree, when theta is 30 degree, will give you 1 by 2. Sin 45, 1 by root 2. Sin 60, root 3 by 2. Sin 91. And so on for any other trigonometric ratio. You can easily find the value. So if you are going in the final exam, do one thing. Create this table first. Because I am sure that there will be a problem from some applications of trigonometry in 5 marks, correct? So you want to score 5 marks and you don't want to waste time. So create this table anywhere in your rough sheet, correct? Then when you are solving that problem, then you can easily use this table. This is very usable. Even in 1 mark or 2 mark, they will give you some problem related to values, na? Then also it is usable. So if you can score 5 to 7 marks from this table itself, so first create the table in the rough sheet, okay? So this is how you can create 0, 1, 2, 3, 4, divide each value by 4, then take the under root, that will be the sine value, correct? Then write the numbers in the opposite order for cos, divide them for tangent, then 1 by sine will be cosecant, 1 by cos will be secant, and cot would be 1 by 10. Easy. Now, this is how you can create table. Done. Now, identity. Identity, as I told you, is a very big part of this chapter, because using identities, we need to solve some problems. We are gonna prove some things. So what are trigonometric identities? In case of algebraic identities, we know that a plus sorry, a plus b whole square, a minus b whole square, like that, correct? And there are multiple algebraic identities, correct, that you know of. In case of trigonometry, trigonometric identity is something which is true for all values, no? Here we are dealing with what? Either side ratios or angles, correct? So an identity, and trigonometric identity is an equation which is true for all the values of the angle for which both sides are defined. So for whatever angle we are defining it, it is always be true. That's why it is known as identity. Now, basic identities, basic trigonometric identities are sine square theta plus cos square theta is equals to 1. 1 plus tan square theta is equals to secant square theta. 1 plus cot square theta is equal to cosecant square theta. Again, if you are finding it difficult to remember this, then how to remember this so that you can use it? Let me tell you one trick for this also. So the trick is, you know Pythagoras theorem. What is Pythagoras theorem? that in any right angle triangle, if in any right angle triangle, square of the hypotenuse will always be equals to sum of the squares of other two sides, correct? So using the Pythagoras theorem, we can easily find these identities. Let me show you. So given a right angle triangle ABC, right angled at B. So now here you can see sine square theta plus cos square theta is equals to 1. Suppose theta is this angle, because we need to consider one angle, na? Then only we can define which side is perpendicular, which side is base. You can also define this as theta, no problem. But the base and perpendicular will change accordingly, correct? Now, if angle C is theta, so of course AC is the hypotenuse, because this is the side opposite. I will refer them using the initials. H for hypotenuse, then side opposite to theta will be the perpendicular. So I will write P here for perpendicular, and the side adjacent is the base. So B for base. Okay. Now, according to Pythagoras theorem, hypotenuse square will always be equals to perpendicular square plus base square. Hypotenuse square means AC. AC square is equals to perpendicular square means AB square plus base square means BC square. Do one thing, divide whole equation by AC square, same value, because I need sine square theta, cos square theta, correct? Perpendicular is AB square, base is BC square. What is sine theta? Perpendicular by base, perpendicular by hypotenuse, correct? What is cos theta? Base by hypotenuse. So here, if somehow I am able to create perpendicular by hypotenuse and base by hypotenuse, then I will get what? Sine theta and cos theta. And they are squared values, so it will become sine square theta, cos square theta, correct? Also, it will eliminate this AC square also, because I need to divide these two by hypotenuse and I cannot change the overall value of the equation. So I need to divide both the sides with the same value, correct? So dividing both sides by AC square. By AC square, we are going to divide both sides. So it will become what? AC square by AC square is equals to AB square by AC square plus BC square by AC square. These two are going to cancel each other. So what are we left with here? 1 is equals to AB square by AC square. We can take this square common, no? So it will become AB by AC whole square. What is AB by AC? AB is the perpendicular, AC is the hypotenuse. It is basically sine theta. Sine theta, but square, so sine square theta. BC by AC is what? BC is the side adjacent or base and AC is the hypotenuse again. So this will be cos theta, but squared value, so cos square theta. As you can see now, this is our first identity. Sine square theta plus cos square theta is equals to 1, correct? So this is how you can find it. Even you can remember this easily now, because now you know na, the relation from where it is coming. So that's why it is easily rememberable. Second identity. Second identity is 1 plus tan square theta is equals to secant square theta, correct? Now we need what? First thing that I can see here, that on right hand side it is secant square theta, the only value. Secant theta is what? 1 by cos theta, correct? Cos theta is base by hypotenuse. So secant theta is what? Hypotenuse by base, correct? So somehow I need to create hypotenuse by base here. Suppose if this is the angle, that is theta, then this is hypotenuse, this is perpendicular, this is base. So on the right side, I will be having AC by BC somehow, correct? So apply the Pythagoras theorem again. So P square plus B square is equals to H square. Perpendicular square plus base square is equals to hypotenuse square. Perpendicular here is what? AB. So AB square plus B square means BC square. Hypotenuse means AC square. I need on the right side secant theta, or basically hypotenuse by base. So I should be dividing whole equation by BC. That will solve two problems. Here I will be getting AB by BC. AB by BC is perpendicular by base, tan theta. I need tan theta, correct? And on the right side, I will be having hypotenuse by base. That will give me secant theta, and also BC by BC is going to give us, correct? So divide whole equation or both sides by BC square. If you do that, it will become AB square by BC square plus BC square by BC square is equals to AC square by BC square. They are going to cancel each other. Here, as we can see, AB square by BC square, square we can take common, it will become AB by BC. AB by BC is perpendicular by base. Perpendicular by base is tan theta, but squared value, so it will become tan square theta plus. This is 1 only, so we cannot do anything. On the right, AC by BC, square we are taking as common. So AC by BC is what? AC is hypotenuse, BC is base. Hypotenuse by base is secant, but squared value, so it will become secant square theta. Correct? Again, you can see the identity, same identity. So we are only applying the Pythagoras theorem, and we are dividing the whole equation by one-sided, and that way you will get your identities. Now third one, now you must be thinking that this is easy, no? Correct? So again, this is theta, so hypotenuse, perpendicular and base. We need what? Cot theta. Cot theta is reciprocal of tan theta. Tan theta is what? Perpendicular by base. So cot theta would be 1 by perpendicular by base. So basically base by perpendicular. So it means I need base by perpendicular, BC by AB. Correct? So first I will write the Pythagoras theorem. P square plus B square is equals to H square. Now P square means AB square. B square means BC square, AC square. I need cot theta means base by perpendicular, BC square by AB square. So it means I need to divide the whole equation by AB square, because I need 1 also. So AB by AB will give me 1. BC by AB will give me cot. And what about AC by AB? AC is perpendicular, hypotenuse, and AB is perpendicular. So cosecant theta is basically 1 by sin theta. Sin theta is perpendicular by hypotenuse. So cosecant theta is hypotenuse by perpendicular. So that will also follow, correct? So divide both sides by AB square. So it will become AB square by AB square plus BC square by AB square is equals to AC square by AB square. These two are going to cancel each other. So it will give us 1 plus BC by AB when square is taken common. So BC by AB, BC by AB is base by perpendicular, that is cot square. Cot theta but squared value, so cot square theta is equals to AC by AB, hypotenuse by perpendicular. Hypotenuse by perpendicular is cosecant theta but squared value, so cosecant square theta. Correct? So this is how you can find the identities, or you can derive the identities. So basically, what are we doing here? We are utilizing the same Pythagoras theorem, considering one angle to be our theta. Depending on that theta, we can realize which side is hypotenuse, perpendicular, and base. Then we are dividing the whole equation by one side at a time. That way, you can easily find all three identities that you are gonna use in this class. Correct? So now you understood the concept how to find the identities. Now we are going to take 5 minutes break, and after this we will be solving various problems based on this chapter that you might be feeling uncomfortable with, how to approach them, how to prove this equals to that, RHS equals to LHS. So these type of problems we are going to consider after a break. So please get done with whatever you are doing and come back in 5 minutes, then we are going to start the session again. Okay, so we are back. So let's continue our discussion on this chapter. So till now we have understood how to find the values of some specific angles, correct? The value of trigonometric ratios for some specific angles. The trick we have understood. We have seen the three basic trigonometric identities also, correct? Now we are going to apply these logics to solve or to prove some problems. Now let's start. So the first problem is prove that secant A into 1 minus sine A into secant A plus tan A is equals to 1. Now, this type of problems are the major headache for you in this chapter, correct? And you are afraid that how to approach such problems, correct? Let me tell you frankly, most of the time, the problem that you are going to deal with can be solved by converting those un, uh, those unrelated trigonometric ratios which are not sine and cos to sine and cos. If you can see different trigonometric ratios in the problem, so try to do one thing, convert all of them in terms of sine and cos. All of them can be converted, correct? Why? Sine and cos are sine and cos, so no need to convert them. But suppose if you are having tangent, then what can you do? You can apply this relationship. Tangent A or tangent theta will always be equals to sine theta by cos theta. So again, you are seeing sine and cos. Suppose cosecant theta is there, so you can convert it to 1 by sine theta, correct? If secant theta is there, then you can convert it to 1 by cos theta, correct? And if cot theta is there, then we know that cot theta is 1 by tangent theta. Tangent theta is sine theta by cos theta. So cot theta will become cos theta by sine theta. So any trigonometric ratio can be converted in the form of sine theta and cos theta. Okay. Now, so in this problem also, we are gonna follow the same approach. First thing first, we are gonna consider the left side only, because in the right side it is only one. Na? If somehow I will be able to convert this value on the left side equals to 1, then we can easily say that RHS equals to LHS proof, correct? So let's do one thing. LHS. Consider only LHS. What is LHS? Secant A into 1 minus sine A into secant A plus tan A. We are going to convert every trigonometric ratio in terms of sine and cos. Okay. Secant A is nothing but the reciprocal of cos. So it will become 1 by cos A. 1 minus sine A is in terms of sine A only. So it will remain as it is, 1 minus sine A. Secant A again. So it will become 1 by cos A plus tangent A is sine A by cos A. Now, we can take cos A common here, correct? And this we can club. So it will look like 1 minus sine A divided by cos A. Here, inside the bracket, we can take cos A common. So the numerator will become 1 plus sine A. Now they are in multiplication, both the values. So if that is the case, so we can multiply the numerators and we can multiply the denominators. So 1 minus sine A into 1 plus sine A. A minus B into A plus B. Remember the identity? So it will become what? A square minus B square. So this will become A square is 1 square, 1 square, 1. Minus B square is sine square A, correct? And in denominator, what do we have? Cos A into cos A. So cos square A. Now we are here now. So let me divide the whole portion in half. So we are going to continue from this portion. We know the identity. Which identity? Sin square a plus cos square a is always equals to 1, correct? So let me use this space. Sin square a plus cos square a is always 1. If I transpose this sin square a to right side, so equation will become cos square a is equals to 1 minus sin square a, right? Here I can see 1 minus sin square a. So in place of 1 minus sin square a, I can directly write cos square a, correct? So here 1 minus sin square a will become cos square a, and in denominator it is already cos square a. They are going to cancel each other. So what are we left with now? 1. So this is your LHS now. This is your RHS. So LHS is equals to RHS now. Hence prove. This is how you can prove this problem. As I told you, most of the time in 80% of the problems, you can do one thing. You can convert every other non-sine cos value to sine cos. You know the relation, correct? That you can use here. Then you are performing basic operations only. LCM you are taking, adding, subtracting, multiplying, dividing. This only you are doing. Then at some point you may be using trigonometric identities also. That way you can easily prove such problems, correct? Easy approach. Now let's see what you have learned so far. So here in this problem, second problem, we need to prove that cot A minus cos A divided by cot A plus cos A is equals to cosecant A minus 1 divided by cosecant A plus 1. So now how to approach this one? Anyone? Again, we are gonna take the LHS, correct? As you guys are saying, we should consider LHS, okay? If somehow we can convert this value back to this one, our work is done, correct? So LHS is cot A minus cos A divided by cot A plus cos A. Now, the same approach we are going to apply here, that we are going to convert every other non-sine cos value to sine cos value. Okay. What is cot A in terms of sine and cos? Cos by sine, because cot A is the reciprocal of tan. Tan is sine by cos, correct? So cot A will become cos A by sine A. Okay. So this will become cos A divided by sine A minus cos A upon cos A upon sine A plus cos A. Now what? As you can see in the right side of the given problem, we need minus 1 and plus 1. Is it possible somehow? Yes, it is. Suppose if I take cos A common from the numerator and cos A from the denominator, then in the bracket I will be having minus 1 here, minus plus 1 here, correct? So, okay. Take cos A common in numerator. Then inside bracket, what are you having now? 1 minus sine A minus 1 upon cos A from here also. Then you must be having 1 minus 1 by sine A plus 1. Cos A and cos A are going to cancel each other. We need cosecant A minus 1 and cosecant A plus 1. Do we have any relationship between sine and cos? Cosecant, sorry. Yes, we do have a relation. That is, cosecant A is always equals to 1 by sine A, correct? Now, 1 by sine A is cosecant A, so it will become cosecant A minus 1 divided by 1 by sine A here also, so cosecant A plus 1. This is what we need to do. Correct? Now, as you can see, LHS is equals to RHS. Hence, proved. Easy. We are doing the same thing, converting every other known sine cos value to sine cos, performing the basic operations, remembering the basic relationship, and then getting the final value. Correct? Now, third part. Here, the problem is cos theta by 1 minus tan theta plus sine theta by 1 minus cot theta. We need to prove this equals to cos theta plus sine theta. Okay. Same thing we are gonna do here. We are gonna convert every other known sine cos value to sine cos and considering only LHS. LHS. Cos theta by 1 minus tan theta plus sine theta by 1 minus cot theta. Now, tan theta and cot theta are two values which we need to convert, correct? Because sine cos are sine cos only. Cos theta by 1 minus tan theta is sine theta by cos theta. Sine theta by cos theta plus sine theta as it is divided by 1 minus cot theta is reciprocal of tan theta, so it will become cos theta by sine theta. Now, we can take the reciprocal here, correct? Then after taking the reciprocal, yes, doing good. Now, after taking the reciprocal, it will become not reciprocal, the LCM, the denominator part will become 1 and there is no denominator part here, so the LCM would be cos theta only. So the denominator part will become cos theta minus sine theta by cos theta plus sine theta by, this will become sine theta minus cos theta by sine theta, right? Now, this can be taken in the numerator part. Same here, we can take this into the numerator part. So, the equation will become cos theta into cos theta is gonna give us cos square theta divided by cos theta minus sine theta as it is. Plus sine theta into sine theta, sine square theta divided by sine theta minus cos theta. Now, look at this. Now we cannot proceed further because denominators are different, numerators are different. We cannot take anything common. But how about if I take minus sign common from the denominator part of the second term? Then it will become what? Cos theta minus sine theta, same as this one, correct? Okay, let's go with this. Cos square theta by cos theta minus sine theta. If I am taking minus sign common, so I need to put that negative sign here. So it will become minus sine square theta by cos theta minus sine theta now. Correct? Now the denominators are equal. So we can perform the operations on numerators. Correct? Directly. So it will become cos square theta minus sine square theta divided by cos theta minus sine theta. Now look at this. If we were having cos square theta plus sin square theta, then we can directly write this one as 1, correct? But that is not possible because the operation in between is negative, minus. So, and also we need cos theta plus sin theta. So it means we need to somehow eliminate the denominator. If I'm looking at this value, cos square theta minus sin square theta, it is reminding me of a square minus b square. So that identity I can apply here. According to that identity, cos square theta minus sin square theta will become cos theta minus sin theta, cos theta minus sin theta into cos theta plus sin theta divided by cos theta minus sin theta. Now look at this. All these terms are in multiplication and division only, no? So we can eliminate these two because they are equal. What are we left with now? Cos theta plus sin theta. The same thing that we need to prove. So now LHS is equals to RHS, hence proved again. Again, we are applying the same concept here also, converting the values in terms of sine and cos, then performing the basic operation. Sometimes you may apply some other than normal logic, like here we are applying the identity, correct? Then we are cancelling the common part, correct? That you need to do, but you will realize this easily because here we need to eliminate the denominator, correct? Because there is no denominator part in the RHS side. So how to remove it? Open the identity. That way we can remove. Now fourth one, prove that secant theta plus tan theta minus 1 divided by tan theta minus secant theta plus 1 is equals to cos theta by 1 minus sin theta. Now this one is a little different initially. Why? If I directly convert them, that will not solve my purpose. If I directly convert them in terms of sine cos, that will not solve my purpose. Although I need to convert them at some stage, correct? Because I need cos and sine only. But initially, we need to apply a different logic. What? First, LHS. So, secant theta plus tan theta minus 1 divided by tan theta minus secant theta plus 1. Do we know one trigonometric identity in terms of secant and tangent theta? That is 1 plus tan square theta is equals to secant square theta. If I transpose tan square theta to right side, the identity will become what? 1 equals to secant square theta minus tan square theta, correct? So in place of this one, I will put that identity here. So why I am doing this? Because I need to get uh, rid of this tan theta minus secant theta plus 1, this whole thing. I just only want 1 minus sin theta, and in numerator only cos theta is there. So I need to eliminate these two things, correct? So first I will convert this one to secant theta plus tan theta minus secant square theta minus tan square theta. So this identity I will apply here. Minus sign will remain outside, okay? This we not touch. Again, we can apply a square minus b square here, correct? So secant theta plus tan theta. You can put this in bracket minus here. I will open the close bracket now. Sorry, square bracket now. and inside a square minus b square, a plus b into a minus b. So secant theta plus tan theta and secant theta minus tan theta divided by tan theta minus secant theta plus 1. Correct? Now look at these two terms, this one and this whole term. Out of these two terms, can we take anything common? Yes, we can. What is that? Secant theta plus tan theta. So if we are taking secant theta plus tan theta common, then we are gonna left with some part. So first write the common that you are taking. Secant theta plus tan theta. Inside, out of this term, what are you left with? 1. Only 1 minus. And from this term, what are you left with? Secant theta minus tan theta. Now suppose secant theta minus tan theta what you are left with. If you are opening the bracket, so it will become minus secant theta and minus minus plus tan theta. So 1 minus secant theta plus tan theta is what you are left with inside. And in denominator, we are left with tan theta minus secant theta plus 1. Tan theta minus secant theta plus 1. If you look at these terms, again, this whole term and this whole term, they are equal, aren't they? Yes. So we can cancel them? Yes, we can. After cancellation, what are we left with? Secant theta plus tan theta. Now, we need the whole value in terms of cos and sine, correct? So are we having any relationship between secant theta and tangent theta? Yes, yes. What you are saying is also true. Now, is there any relationship between secant theta and secant theta and tangent theta in terms of sine and cos? Yes. Secant theta is 1 by cos theta. Tan theta is sine theta by cos theta. Still, we can take cos theta common, but the main problem will become that in numerator it is 1 plus sine theta, in denominator it is cos theta. But I need cos theta in numerator and 1 minus sine theta in denominator. Okay, what to do now? See, if somehow I will convert this 1 plus sine theta into cos theta and cos theta into 1 minus sine theta, then my problem is solved. But how to do this? I can do one thing. I can multiply the whole expression with 1 minus sine theta. Why would I do that? If I multiply whole expression with 1 minus sine theta and divide with the same value also, then in numerator I will get 1 square or 1 minus sine square theta. That is equals to cos square theta, correct? Not exactly equals to cos theta, but closer. And we will see what changes we can see in the denominator also. So multiply with 1 minus sine theta by 1 minus sine theta. A plus b into a minus b. A square minus b square or 1 minus sine square theta divided by cos theta into 1 minus sine theta. Look at this. This is cos square theta. 1 minus sine square theta is cos square theta divided by cos theta into 1 minus sine theta. Cos theta and square are cancelled. Now what are you left with? Cos theta divided by 1 minus sine theta, same RHS value. So from here we can simply say that LHS is equals to RHS. The only different thing that we are doing here is we are converting this value to secant square theta minus tan square theta. And after that we are taking common, cancelling the common parts, then we are again converting values back to sine and cos, correct? Now this one, prove that under root of 1 plus sine theta by 1 minus sine theta plus under root of 1 minus sine theta by 1 plus sine theta is equals to 2 secant theta. This problem did appeared in the exams before, in the board exams, but this is very easy. This is easier than the previous one. How? First thing, as you can see, this is having under root value, so this might confuse you, correct? No, please don't. Uh, please don't feel pressured now. Again, same thing, LHS. LHS is under root of 1 plus sine theta by 1 minus sine theta plus under root of 1 minus sine theta by 1 plus sine theta. This is LHS. So under root we can separate, correct? This basically means that under root 1 minus sine theta divided by under root 1 minus sine. Oh, this is 1 plus sine theta, no? Yeah. This basically means that under root 1 plus sine theta divided by under root 1 minus sine theta. Now, this means that under root 1 minus sine theta divided by under root 1 plus sine theta. So we can separate 1 plus sine theta divided by under root 1 minus sine theta plus under root 1 minus sine theta divided by under root 1 plus sine theta. Take LCM. What will happen? If we are taking LCM, then this term and this term we need to multiply. So it will become squared value, square and square root are gonna cancel each other. Same goes for these two terms. They are gonna multiply each other. Then that way it will become squared value, square and square root are gonna cancel each other. Correct? So take the LCM. LCM would be 1 minus sine theta in under root multiply under root 1 plus sine theta, and this value will become under root 1 minus sine theta into under root 1 minus sine theta squared value, so under root 1 plus sine theta whole square plus this will become under root 1 minus sine theta whole square. Square and square root are gonna cancel each other, correct? So what are we left with now in the numerator? 1 plus sine theta plus 1 minus sine theta divided by this value minus sine theta plus under root, this is 1 plus sine theta, correct? Sine theta and sine theta are gonna cancel each other, so this will become 1 plus 1 2. So here I will use this space. 1 plus 1 2. In denominator what are we having? Under root we can take, why I'm writing plus here, there is no plus sign here. Under root 1 minus sine theta into under root 1 plus sine theta, when they are multiplied it will become under root a plus b into a minus b. So it means under root a square minus b square. So this value will become 1 square 1 minus sine square theta. Now 1 minus sine square theta is cos theta. So this will become 2 by under root cos square theta. Under root and square are gonna cancel each other. So this is 2 by cos theta, but cos theta and secant theta are reciprocal of each other. So 1 by cos theta I can write as secant theta. So this will become 2 into secant theta. This is how you can approach this problem. So this is easier than the previous one, no? So what are we doing? We are just taking the LCM first. Then we are seeing that it will become squared value, square and root are going to cancel each other. Here we can see that under root, after taking under root common, this will become an identity a plus b into a minus b, simply a square minus b square. But here in this case, a square minus b square is 1 minus sine square theta. That is one more trigonometric identity, that is sine square theta plus cos square theta is equals to 1. So from here we can replace this value with cos square theta. Again square root are going to cancel each other and 1 by cos is secant theta. So the final answer will become 2 secant theta. Understood? Understood everyone? Please let me know in the chat box. Understood? Correct? Now, this problem. Cosecant theta into, cosecant theta divided by cosecant theta minus 1 plus cosecant theta divided by cosecant theta plus 1, we need to prove this one to be equals to 2 secant square theta. Similar type of problem, but we are gonna deal with cosecant theta now. So what are we gonna do here? First thing, we are gonna take the LCM again. That way, we are gonna multiply this value with whole, this value and this value with this value whole. And when they are being multiplied with themselves, it will again give us the identity a square minus b square, correct? So LHS. So I'm just directly taking the LCM. First, you need to write the LHS also, but I'm directly writing the LCM. I am directly taking the LCM. So it will become in denominator cosecant theta minus 1 into cosecant theta plus 1. And here it will become cosecant theta into cosecant theta plus 1 plus cosecant theta into cosecant theta minus 1. Multiply them. Cosecant into cosecant, cosecant square theta plus cosecant theta. Here again cosecant into cosecant, cosecant into minus 1 minus cosecant theta divided by a minus b into a plus b, a square minus b square. So cosecant square theta minus 1 square is 1 plus cosecant theta minus cosecant theta are going to cancel each other, and cosecant square theta plus cosecant square theta will become 2 cosecant square theta. Now, do you remember the identity that cosecant square theta is equals to what? Cosecant theta, cosecant square theta is having identity 1 plus cot square theta, correct? So we are gonna put that value here. Minus 1. They are gonna cancel each other. So what are we left with? Okay, let me use this space. 2 cosecant square theta divided by cot square theta. We need to convert this into secant square theta. So if you know the relationship, you can directly go with secant square theta relationship. But if you are not sure, then you can convert these values to sine or cos in terms of sine and cos. So look at this. 2 cosecant square theta is having a relationship with sine. So it will become 1 by sine square theta. So 2 into 1 by sine square theta divided by cot square theta is cos theta by sin theta. So squared value cot square theta by sin square theta. Cos square theta divided by sin square theta. Now look at this. Sin square and sin square theta are going to cancel each other. What are we left with? 2 divided by cos square theta. 1 by cos theta is secant theta. 1 by cos square theta is secant square theta. So this is going to give us 2 into secant square theta. LHS is equals to RHS. Hence proved. This is how you can approach this problem. So there's nothing that we are doing extraordinary here. We are just taking the LCM, opening the brackets, subtracting what is common, then adding, then applying the identity here. So the main step is this one, that you need to realize that cosecant square theta is 1 plus cot square theta. 1 and 1 are going to cancel each other, converting these values back to sine and cos. Also, although you can directly go with other values also, that you can that can help you in converting back into secant square theta, but if you are not sure, go with sine cos. They are easier to remember. Then after looking at this, we are getting 2 divided by cos square theta. 1 by cos square theta is secant square theta. So we are getting LHS and RHS as equal now. So this is how you can approach this problem. Let's solve one. Here in this problem, we need to convert sine A by 1 plus cos A plus 1 plus cos A by 1 plus cos A by sine A to 2 cosecant A. Same approach we are going to apply here. Cosecant A we know is having a relationship with sine, correct? That is 1 by sine. So here all the values are in terms of sine and cos only. So directly find the LCM then. Okay, LHS. Taking LCM is, it will become what? Sine into, okay, let me take the LCM. 1 plus cos A into sine. Correct? Sine A into sine A, sine square A, plus 1 plus cos A into 1 plus cos A, 1 plus cos A whole square. Okay? Please don't get confused yourself. 1 plus cos A into 1 plus cos A would be 1 plus cos A whole square. So it will be 1 plus cos A whole square. Now, open the identity. Sine square A plus A square, because this is A plus B whole square. So A square means 1 square, 1, plus B square means cos square A, plus 2AB means 2 cos A, divided by, I will not touch these, 1 plus cos A into sine A. Now, sine square A plus cos square A, 1, identity. So this is going to give us 1. This one as it is, plus 1, plus 2 cos A, divided by 1 plus cos A into sine A. As you can see here, 1 plus 1 is 2. So let me use this space. And plus 2 cos A as it is. So this will become 2 plus 2 cos A divided by 1 plus cos A into sine A. If I take 2 common in numerator, what will I get? 1 plus cos A. In denominator also we are having 1 plus cos A. So that's why I didn't multiply them, so that I can cancel them. Correct? So 2 we are taking common, 1 plus cos A is what we are left with. So 1 plus cos A in denominator into sine A. We are going to cancel them. Also, we know the relationship. Cosecant theta is always equals to 1 by sine theta. Here we are having 1 by sine A, so it will become cosecant A. So 2 into cosecant. This is your LHS, this is your RHS, they are equal. Hence, prove. This is how you can prove this one. So we have seen different approaches, no? But most of the time, what are we doing? Either we are converting values back to sine and cos, correct? Either we are applying the trigonometric identities, you need to remember them. If you are not able to remember them, I already told you the trick how to find them, correct? That you can apply. Then basic operations only. So now we have seen different type of problems and we are done with this. So let's see what we have understood in this session. In this session, we understood the different trigonometric ratios of some specific angles like 0, 30 degree, 45, 60 and 90 degree, correct? How to create the table, I told you the trick. How, please utilize that trick. That way you can make sure that you will be getting at least 5 to 7 marks very easily, because that table is applicable in this chapter also, in the next chapter also, some applications of trigonometry. Then we have seen three different trigonometric identities, correct? Then we have solved some different problems. So we are done with this chapter. There is nothing left. Even if you are still having any doubt, you can ask us in the comment section. We will try to take them and we'll try to solve them. And for more such videos, yes, please stay tuned. Okay. So till then, I'm gonna end this session. I hope you gained something from this one. We'll meet you soon.